Okay, in this video, we're going to be looking at the homework problems in section 9.4 that deal with odds and then expected value and conditional probability. The first problem is this: if the probability of a child being a boy is 1/2, and a family plans to have 4 children, what are the odds against having all boys? Okay, so let's look at this particular situation here. You're going to have all 4 boys. So that means the probability of the first boy is 1/2. The second boy is 1/2. The third child being a boy is 1/2, and the fourth child being a boy is 1/2. So if we do 1/2 times 1/2 times 1/2 times 1/2, that's 1/16. That's the probability of 4 boys. Okay, but we want the odds against having all boys. Okay, now we talked about a formula for the odds against, which is always going to be n. Actually, the probability of, well, let's say 1 minus the probability of event A divided by the probability of event A. And by the way, in this case here, if you recall, odds against is always the reciprocal of the odds in favor. So this is 1 minus the probability of event A, and we're letting event A be having all 4 boys. So this will be 1 minus 1/16 divided by 1/16. Okay, so in this case here, 1 whole is 16/16, so 1 minus 1/16 will be 15/16 divided by 1/16. And then if we simplify this will be 15/16 times the reciprocal of 1/16, which will be 16/1. And that will be 15/1 when you simplify this. And they want this written as odds are blank to blank. So it'll be 15/1. So when you fill in your answer, it'll be, in this case, 15/1. Those are the odds against having all 4 boys. Okay. Problem number 2. If the odds against Deborah's winning first prize in a chess tournament are 4/11, what is the probability of the event that she will win first prize? Okay, so in this case here, her odds against are 4/11. So in this case here, the probability of winning, and the formula for that is this. You have n divided by m plus n. In this case, your m is the first number, your n is the second number. So in this case here, your n in this case is going to be 11. So that'll be 11 over m plus n. That's the sum of those two. 4 plus 11, which will be 11/15. So the probability that Deborah will win first place is 11/15. Okay. All right, number 3. Find the odds against a randomly chosen household having a cat if the probability of an event that a randomly chosen household cat is 0.27. Okay, so here we're looking for the odds against. And that's always going to be 1 minus the probability of event A divided by the probability of event A. In this case, we're looking at the probability that, well, the event A is going to be a household having a cat. So the probability of that was 0.27, so the numerator will be 1 minus 0.27 divided by the probability of event A, which is 0.27. So the numerator is going to be 0.73 when you do 1 minus 0.27. The denominator is 0.27. Okay, now what I'm going to do here is convert 73 hundredths as a fraction, as 73 over 100. And 20.27, that's 27 over 100. So now you got 73 over 100 times the reciprocal of 27 over 100, which is 100 over 27. The hundreds divide out, you get 73 over 27. And the reason why I did that, because they want it written in this form with a colon in between. So they want that to say 73 to 27. So it'll be 73 to 27. Okay. All right, problem number 4. If the probability of an event happening is 81 over 98, what are the odds against it happening? Okay. So again, we're looking for the odds against. And we're going to be using that same formula that we used in the last problem. So odds against is always going to be 1 minus the probability of event A divided by the probability of event A. So the numerator will be 1 minus 81 over 98 divided by 81 over 98. Okay, so 1 whole is 98 over 98 because the denominator is 98. So if you do 98 minus 81, you're going to get 17. So it'll be 17 98ths in the numerator and 81 98ths in the denominator. Now let's simplify this by doing 17 98ths times the reciprocal of 81 over 98, which is 98 over 81. Those 98ths divide out, you get 17 over 81. And if you were to write this, it'll be 17 to 81. So the odds against this event happening will be 17 to 81. Okay, problem number 5. Suppose 10 quarters, 5 dimes, 7 nickels, and 2 pennies are in a box. One coin is selected at random. What is the expected value of this experiment? Okay, so this is one of the problems where you're dealing with expected value. Okay, there are 10 quarters. A quarter has a value of 25 cents. So now you're going to have, and we're going to let E be the expected value, 10 times 0.25. Because there are 10 quarters. Each quarter is the value of 25 cents. There are 5 dimes. Each dime is worth 10 cents, so it'll be 5 times 0.10. And 3 nickels are worth 5 cents each, so it'll be 3 times 0.05. 2 pennies, that's worth 1 cent, or 0.01. Okay, so here we just simplify this. Now 10 times 2.25 will be 2.5, or $2.50. 5 times 0.10, or 10 cents, will be 50 cents. 3 times 5 cents will be 15 cents. And 2 times 1 cent will be 2 cents. Now if we were to add these together, using the calculator, $2.50 plus 50 cents plus 15 cents plus 2 cents, you'll get $3.17. see, $3.17, and then if I take that $3.17 and divide that by 20, I'm going to get this 0.1585 because there are 20 coins in the box. So we take the cost, the value of all those coins, and divide that by 20. Now, if you round this off to the nearest, to 2 decimal places, it'll be approximately 0.16 or 16 cents. So the expected value would be 16 cents. Okay, the next problem. This also deals with odds and also expected value put together. If the odds in favor of Fastlegs winning a horse race are 8-3, and the first prize is $66,000, what is the expected value of Fastlegs winning? Okay, so now we need to know what the probability, because we know the odds in favor are 8-3. So here the probability of Fastleg winning is going to be this: M divided by M plus N, as we're given the odds in favor. And in this case, M is the first number, N is the second number. Okay, we know the odds in favor, so we want the probability of winning. So here we're going to use M, which is your 8, that's your numerator, divided by M plus N, which is 8 plus 3. So in this case here, that probability of Fastlegs winning will be 8 out of 11. And in this case here, the first prize was $66,000. So here, the expected value will be the first prize amount, which is $66,000, times the probability of Fastlegs winning, which is 8 out of 11. So if we do 66,000 times 8 divided by 11, you'll get $48,000. So the expected value here for Fastlegs winnings would be $48,000. Okay. So here we have to find out what the probability is because we were given the odds in favor. And then from that, we can find out what the expected value is by multiplying that dollar amount times the respective probability. Okay, the next problem, number 7. Suppose the odds against winning the lottery is 43 million to 1. What is the probability of the event of winning the lottery given these odds? Okay, so here we have the odds against. So the odds against are 43 million to 1. And we want the probability of winning. Now we're given the odds against, so we have to use M divided by, take that back, N divided by M plus N. Okay, because it's odds against. So N is your numerator, your denominator is always M plus N. The N is the second number, which is 1, divided by the sum of the two, 43 million, plus 1, which will be 43 million, 1. Okay, and that's going to be your answer right there. So here the probability of winning the lottery given those particular odds would be 1 over 43 million, 1, which is quite a low probability because, lotteries, odds are the probability of anybody winning the lottery is very, very low. Number 8. What are the odds in favor of randomly drawing the letter C from the letters in the words successes? Okay, the odds in favor. Okay, so let's look at this here. Odds in favor. Let's look at the probability of drawing the C in the word successes. Okay, there are, in this case, 9 letters in the word successes. 2 of the letters are C. So the probability there of drawing a C would be 2/9. Okay, now we're trying to find the odds in favor of drawing a C. That's going to be the probability of drawing a C divided by 1 minus the probability of drawing a C. And 1 minus the probability of drawing a C is the same as the probability of the complement of C. The probability of drawing the letter C will be 2/9. That's your numerator. The denominator is going to be 1 minus 2/9. Subtract 2/9 from 1 whole, which is 9/9. That'll be 7/9 in the denominator. And your numerator will be 2/9. So in this case here, you'll have 2/9 times the reciprocal of 7/9 will be 9/7. Divide out the 9s, you're going to get 2/7. Or another way of writing that would be 2 to 7. So the odds in favor of randomly drawing the letter C from the letters in the word successes are 2 to 7. All right, number 9. If the probability of an event is 0.5 with a bar on top, what are the odds against the event? Okay. In this case here, 0.5 with a bar on top. That's going to give you 4/9. Correction will be 5/9. Okay, because you have one number repeating, so we'll put the 5 on top, and for one number repeating, we'll put the denominator with a 9. So it'll be 5/9. And the odds against is this. 1 minus the probability of that event, which is 5/9, divided by 5/9, the probability of that same event. Well, one whole, which is 9/9, minus 5/9, that's 4/9, divided by 5/9. And we can write this as 4/9 times the reciprocal of 5/9, which is 9/5. The 9s divide out, you're left with 4/5, or as a ratio, 4 to 5. So the odds against the event will be 4 to 5. Okay. And finally, number 10. If the probability of an event of rain for the day is 58%, what are the odds against that it would rain for the day? Okay, so we want the odds against. Which is in this case 1 minus the probability of it raining, which is 58%, but as a decimal, that's going to be 0.58, divided by the probability of that event happening, which is 0.58. Okay, now think of this as $1 minus 58 cents, which will be 42 cents, or 0.42, divided by 0.58. Okay, now if I write 42/100 as a fraction, that'll be 42/100. And 0.58 as a fraction, that's going to be 58/100. So now we can simplify this by saying 42 over 100 times the reciprocal of 58 over 100, which is 100 over 58. The 100s divide out, you're going to get 42 over 58. And this can be reduced by dividing the numerator and the denominator by 2, so it'll be 21 over 29. And as the ratio, it'll be 21 to 29. Okay, because they want us to simplify the answer. So the odds against raining for that day will be 21 to 29. Okay. Now this should assist you with some of the homework problems in section 9.4.